Yes, thank you. So on behalf of everyone at Bestseller, I would just like to introduce the prizes that we have for all the participants. So the third prize would essentially be this book called Effective Python with some really nice examples and best practices. So that's the third prize. The second prize is going to be the Raspberry Pi Model 4 with 4 gigs of RAM. Sounds really nice. I would like to have one. Thank you. And then for the first prize, or the major prize, it's going to be a, where is it? It's over here. So it's a shopping voucher worth 100 euros for shop.bestseller.com. It says there, 100 euros. So the only thing you need to do to win one of these is to enter the quiz that I will just post quickly on Slack. Answer 3 very simple questions, and you will be eligible to win one of these prizes. Thank you to everyone who's going to try so. Bye-bye.
Nice. So we have really nice prizes today. So that's going to be a raffle after the talks. And I think, okay, so 5 minutes after 6, so we are ready to go. So we're going to have our first speaker today. It's going to be a talk about modular threaded design pattern in Python microservices. And yeah, Clayton, I think you can introduce yourself. And
yes,
that's
yes.
going to be a lot better than me.
Of course, of course.
Thank you. Thank you for, by the way, thank you for presenting. And thank you, Bestseller, for hosting us. And yeah, go away.
It's always a pleasure if we can share information, right? This will be my first meetup since moving to the Netherlands that I'll be joining. So thank you very much for having me. I am just going to start sharing my screen in a moment, so you can see what I'm doing and what I'm presenting. Right. So let's move this up. Yeah, let's give it a moment. Apparently, there we go. You guys all see my screen, just confirmation, right?
Yeah, but we are seeing the next slide also. I don't know if that's what you want.
Yeah.
So we are seeing your second screen, basically.
So I need to switch it? Oh, hang on. We'll get there. We all know this feeling, right?
For the people that doesn't know, the speakers are in the Bestseller offices today. So we have Santiago there, and they have a nice setup. There is a nice picture on the Slack and on Twitter.
Oh, here we go. Okay. So apparently I got it together now. Let's try again.
Okay.
No.
Still seeing the second one.
I'll switch it now.
I think, right.
Please.
So
Jelle over here, he really helps us.
Yeah, and I think it's time for some Python jokes.
Py jokes. Okay, let's read some Py jokes.
Right, so yeah.
Oh, this is in PowerPoint.
If
So
anyone...
I'm just going to sorry, I'm just going to repeat that there is a link to a spreadsheet in the Slack. So if you want to propose a lightning talk, that's the place to go. A lightning talk is a 5 minutes talk about anything you want to talk about. Good for you is that you have 5 minutes. Good for us, it's only 5 minutes if we don't like it. So yeah, you're welcome to present. And now a lot of Py jokes.
Yeah, if anyone doesn't know what the Py joke is, Py jokes is jokes as a service. It's a Python package and also API where you can get jokes.
Yeah, it was working fine, right?
And you can use it as a CLI application.
Open the slide again.
Just type PyJoke in your command line and have a good laugh.
Yeah.
So let me try some.
So
one of the comments says use slideshow.
So I would say if you don't know how to change that, this view is also probably good.
I know.
So there is one joke. My friend is in a band called 1023 megabytes. they haven't got a gig yet.
A good one. That's a good one, right?
Cool.
You guys
So
can...
you're ready to go.
All right. So it seems like you are seeing my screen now, right? Properly.
Yes.
All right. So swapping displays is not a good idea while you're live in front of so many people. Right. Quickly, I'm going to be presenting modular multi-threaded processes in Python microservices. It is something we have built very recently and actually still in the process of doing, but it has proven to be quite effective in having our team perform better and better each sprint. So I thought I would share a brief overview of how it works and how we went about this. To give an idea, I will be giving you a little bit more information about me. Then I'm going to tell you a story that's going to be more or less why we needed to deliver faster and couldn't just continue on our normal pace. Then I'm going to share with you the requirement and the idea we had. I'm going to share the basic structure of threaded design in Python, right? It might be something that you have come across before. It is not something new, but it might be a good idea to revisit like we did, and we'll show you why. I'll explain the importance of models in our whole idea, and then what the outcome was. So in between, I'll be switching between the show and actual code so that you can see what the whole thing is about. If you guys have any questions, obviously, you can ask them in Slack, right? If I'm not mistaken, or...
Yeah, so we have the Slack channel, or people can raise their hand.
Yes.
But then if you raise the hand, you will need to talk. So I would say let's keep that for the end.
Yeah. Okay, so there will be a Q&A period at the end where I'll take any questions and hopefully provide you with the satisfactory answers you want. Right, so let's quickly go for it. So about me, I am from Johannesburg, South Africa. I moved to the Netherlands about 1.5 years ago only. So the European development scene compared to the African development scene are two different worlds completely. It's been quite an experience. I am married with 2 daughters. I love music, which is kind of weird. Not a lot of people has the combo of I code and I like music so much, right? But apparently I'm one of those. I've been actively developing since 2005. Prior to that, I have been dabbling in code, but only as an interest. In 2005 only I started really getting into it. I worked in industries for marketing and finance, media streaming, disaster and emergency management, and my latest is fashion e-commerce. Then my favorite languages in order, right, is Python, JavaScript, PHP, and then Java. Those are the 4 languages I mainly code in. And then front-end languages, I really enjoy React, Angular, and obviously jQuery, as it was the first interfaces I ever had with front-end. So that is me in a nutshell. You'll see my email address there. You'll see my LinkedIn account there. Should you ever want to contact, you can just go back to those, and then we'll talk about whatever it is you want to talk about, right? So that is me. Let's quickly go and start the story here. So about 4 months ago, I moved teams within our company from the omnichannel, which was purely Java-based, to a Python-based team for master data. Our primary job is to facilitate the enrichment and the creation of product information that is hosted on our website. Our primary job is to... Sorry, I just had some feedback, so I heard my own voice. And anyway, so our primary job is to do that. Complexity comes into the fact that for a while we've been running on a legacy system in the middle that houses the database for all of this. And with the years, a lot of imports and exports of our data was built onto this system. So when we got the requirement that we now need to replace our information system, we realized a lot of hard work is needed for us to first get all of these outside imports and exports pulled out. And so we began with our export service, which is what I'm going to be showcasing pretty much today. I'll be showing you guys like a watered down version of this. It's not the entire system, but just to prove and show the concept a bit. Right. So our problem was this. We were 4 members in our team. We accepted that we're going to replace the legacy code. And then we got the news that 2 of our members was moving employment somewhere else, which happens to the best of our teams all around, right? But we already committed. Everybody kind of wanted the stuff right now. So our initial plan was to deliver the export service within a quarter. That gave us roughly 4 to 5 sprints. We chucked that plan out of the window completely and decided to go all in as quickly as possible we can, because we technically had our 4 members only for 4 weeks. That's 2 sprints in bestseller terms. So we made a plan. And this was it. Right, so the scope was build a service that can query an endpoint and save the results in various formats to different S3 buckets. So most of our product data gets moved around that way and then gets put onto Kafka, onto different other places, right? But the main export function provides a file. So all our old legacy code pretty much was purpose-built. So if we had one export that went to one type of place, then there was a purpose-designed script for it, which made it quite difficult to build generics in this case, right? Because each thing has different business logic in it. We decided to build a generic export service that you can configure using a YAML file, and then it outputs in various formats, whether it be JSON, CSV, XML, because of the different requirements of our partners. Right, we decided to go multi-threaded for a very simple reason. Initially, it was because we deploy on ECS, and they require us to have a health endpoint to stay active. So if you're running Python, you know it's single-threaded. So to run 2 processes together, you've got options. You can go async IO, or you can go threads. Async IO wasn't playing along nicely, so we stuck with threads. We approached this by saying we are not going to focus on any business logic in the beginning. We purely built the flow of our entire sequence of events that needs to happen. So from the moment we receive a file, everything we need to do after that, every step. So if we need to read from the file, that would be in a separate thread. If we were to transform those elements, it would be another thread, so on and so forth, all the way to another thread that eventually uploads this transformed data somewhere else. So it can quickly grow into a big program if you've got a lot of steps. But in our case, that wasn't the case. We just went along, and I think at the end of the day, we've got 8 threads currently running with different queues connecting each to the other. I'll explain to you exactly how that works later. And that basically caused us to be able to split our work into 4 all the time. Because our threads only work on a first in, first out basis, we could also control exactly in what sequence events happened throughout our threads. But I'll explain a little bit more on that. How we approached it was we branched off of our master, and then each developer branched off of that branch. So it was like a sub-branch. Then each developer did their piece, their little thread, tested it in its completeness, and committed all that code to the development branch. When we did the integration afterwards, we had a single pull request that eventually delivered the code to master. So here's, in a nutshell, how the app works. So if you look at the nice design I've got over there, you'll see that we've got 2 components highlighted in green. Those are your initiation components. They all read from a configuration file. And then if you look from scheduler downwards, you'll see that there's a GraphQL query, then a validation, transformer, file writer, and eventually an S3 uploader, all separated completely, each one having a single job to do. Complexity comes in when the scheduler, for instance, let's go back, creates a single message, sends it on a queue to the GraphQL worker. GraphQL says, I need to go and fetch data based on the configuration I received. It goes along and goes and fetch anything from 100 up to 50,000, 100,000 records of our data. And then it starts spewing them out one by one to the validation queue. So some of you are already going, ooh, yeah, because now I don't have a single process anymore that can tell me when the file must stop being written to, right? Because I very much took that first message and split it into many and expecting everything to just go into a single file. I'll show you how we did that at the end of the day. So this is pretty much what the important part of this looks like. So in Python, you can see, obviously, this is my main file. I'll show you the code in a moment. This is my main file. We've got a setup there for different queues. In this case, the sample application I've got has 3 queues, right? A trigger queue, a transformation queue, and a writer queue. Then I create threads called the controller, which is what we will trigger an export on. The request, which in this case goes along and makes an API request and collects data and also sends it out in one record at a time to the transformer queue, which will then either transform it to JSON or to CSV in our examples case. And then we've got a file writer that will write to these files and then close them off. So we do not have the S3 upload component or all the complexities that I explained to you just now, but just this little rundown version. So let me quickly, I'm going to end the slideshow now for a moment to flip back to my code so you can see the whole thing running. Right, so yes, there we go. So to give you an idea, I was lazy, like most developers, right? And I created my config in a Python file, but usually this would be either JSON or YAML or whatever convention your company or you prefer for that case that will load the config into a structure that looks something like you're seeing right now, the config structure. What we have there is a name for my export. I've got a transformer called JSON, a request URL, which you guys can see is local hosted, and then a file name pattern which says that it will be saved using this file name, and there's a little bit of logic in here that goes along and replaces those 2 brackets with a date stamp. Right, so let's quickly look at what this thing is actually doing. So skipping all the imports and the boilerplate code that I've got there, the important part I want you to focus on is the fact that I am importing all my workers into one place. This piece of code you've already seen, the queues and the threads, right? So what I want you to focus on here is to look at how we pass the queues as arguments to the controller worker. We pass a trigger in because controller needs to send information out. The request thread is currently listening in on trigger, and it will output to transform. And then you can see the same pattern on the next one going, it will receive from transform the transformer queue and then output to writer. And then writer does nothing. It's the end of our sequence. It will just write. So I think I'm going to skip the slide in this case because I can just explain. This might seem a bit abstract because of various things going on in your brain right now with how programs work. But in this case, the important part is not this thread and queue. This is just what makes it happen. The important thing here is the models we use in communication with those threads. That's what makes the magic happen. So we decided on a single, plain, small data class called queueMessage. It contains a process name, a transformer, a name, a file name, a request URL, and data. So as you can see, the bottom 2 is not required because not all threads will need them. Only certain threads will need the request URL, like the request thread, and only other threads will need the data, like the transformer and the writer threads. They will use that. So in this case, whenever we create a queueMessage, those items must be there, and these are not always there. But what I want you to look at is the fact that all of this information that I've got highlighted now up to request URL is present in our config file, including the name, which is the key in our config dictionary we've got here. Right. In here, I define that process must be a process type, and transform needs to be a transform type. So let's quickly look at transform type first. It's very simple. It's an enum that tells me you either need to use JSON or CSV. And if we go back to the config, we'll see exactly that is what I passed. Right. So that's my transform types. So in the process types, though, that is not for our config. That is for our application to use. We've got 3 process types, one called export, one called start of process, and one called end of process. So what we basically do is when we trigger an export, thank you. When we trigger an export, we will first send in the start of process. Each thread that we have will go along and see, this is a start of process. I don't need this, pass it on to the next thread. And it will just output to the output queue. And so on and so forth until it hits the file writer, in which case the file writer goes, okay, this specific export has sent me a start of process with this file name, open the file. Each consequent message that comes with export as a process type will then be written to that specific file. And because each one is tagged with a proper name, I'm using that as index. I'll show you that code later. So then it writes to the file continuously. And right at the end, I get a end of file, which basically tells me to close off everything we've been doing. So let's see how that looks in reality, right, in our workers itself. So controller worker we see here, let me just move this. It's a Flask application, right? I think most of us working in Python has used Flask before. As you can see here, I was naughty again. And I forced it to prod, or else it will tell me that I need to use a better server than the development one, right? And I was sick of the error messages, so that's what I did there. But technically, this is the worker. I pass the trigger queue to a global object because I need access to it on the export route there. And then I start running the application on port, in this case, 8800. Right, my export trigger endpoint. So when I send export a message, a get message in this case, the following will happen. It will request the export name from the URL I'm sending, right? It will create file stamp, the file name required, and then it constructs the start message. So as you can see here, it just says the process is SOP, which I will show you later on where that process actually affects. After that, I take that exact message and I just change the process type to export. And after that, I do the exact same thing again and change it to end of process. Then the sequence in which I send them into the trigger queue is important. I send the start message, then the export message, and then the end message. Because we're working with a first in, first out queue basis, what will happen here is the following. The controller will basically make the request worker come alive, where we go and get this. The first thing that will happen is we will get a different process type to export, in which case it just needs to pass on. So the first thing that will happen, we'll get start of process, it will pass it on, then we'll get export, in which case it does the following. It goes and gets the request URL that was sent, so it goes and gets the data. And then for every item it received, it will basically go along and put a message called transform message. So I just basically deep copy the incoming message and I added a data item because all other information needs to stay the same. I always need it. And because it was configured in the beginning, I don't need to change it ever. So I can deep copy the object the whole time so I don't overwrite references. So what would happen here if I've got 3 records, 3 separate messages would be sent out to the transform queue. Our transform worker will then go along, and this is kind of where some of the magic happens, right? And first of all, it will also do the same thing. Sorry, there we go. If it's not export, pass it on. Right, the next thing we do is when there's an export coming, which is now a single record in the data property, we basically go and check for 2 things. Is it JSON or is it CSV, the transform type that I must transform to that was configured right in the beginning? So here I do basic things like I do a JSON dump on the data, or in CSV case, there was a few things that I needed to sort out. Like everything needs to be strings before you can join, right? So then I join it using this method, and then out it goes to the writer queue. Our writer queue, right, again does the same thing, except this time we have got different if statements altogether. We've got export, start of process, and end of process. So if you remember correctly, through our entire flow now, what happened was we sent SOP first, which means it got passed on from thread to thread all the way to here. And then we get SOP here. So here what I do, though the name that I receive in my queue message will become an index into an array where I open a binary writable file. And that is it. Right, you'll also see that if the transform type is JSON, I already add the opening bracket to the array that I'm going to be creating inside this JSON. With CSV, it's not necessary. I decided not to go with headers, right? So you can add logic later on if you want to always add in headers or something. But in this case, not. So this is why we've got the transform types, because with how we write the file might require extra characters or less characters, so on and so forth. So that's the start of process. Next thing that happens is we receive all our records via the export process, in which case it will ask again, is it JSON, is it CSV? Because it needs to know how to encode it. We write in binary because we don't want to lose any of our line breaks that we've got in our data. Sometimes it's important for us as a data central data team, right? So we encode in binary. But when you encode some values like RNN in CSV, you need to Unicode escape. So this is why we still got the transform types that we defined in the beginning at play here. And again, just ending with a new line. So this will continue happening, looping until it received the last of the records, in which case what happened was in our request queue where this data was requested, before it went and got the end of process, it first finished sending all the information required. So the end of process is literally the last thing that runs through your queue. And then what would happen is you would end up with a file somewhere, or you can then decide what you want to do with it or everything. And then that's it. So let's quickly see how this works, right? Because the proof is in the pudding. So let's start off simple. I'm going to show you what I've got. In here, I've got a little Node-RED server set up. For those that haven't worked with Node-RED before, go and give it a try for little things like this where you quickly want to put something together. It's amazing. Right, so I've got mock API endpoints. My endpoint 1 basically waits for records, and it sends in this little data. So just 3 little things called, with name, surname, and an age in it, and that's all that this returns. Then the next one, though, has got 1,000 records in them that it returns when you request the different endpoint, which in this case is records 2, appropriately named. Right, so what you see here is basically just the reverse. This is the server. This is like a type of client. So I will be making a request to my endpoint that looks like this. So export, and then the export name. In this case, that will be export 1, and the other one will be export 2. Right. So because I want you to see it happen, let's quickly start this application now. Right, there we go. So there we go. What do we see happened here? We saw that the main application got started. It means we're starting build threads, right? Then we've got a controller that started, a request thread that started, a transform thread that started, and a file writer that started. All of them kind of at the same way. Now this little bunch here is what Flask spews out. And as you can see, that arrived after all the threads was initiated. This gives you an indication of how asynchronously this actually functions and how you get that data back in your logs asynchronously as well. So you must be careful when building this that you don't think something has happened that hasn't happened yet, right? The logs are not always an indication of when what happens. Because we're using the same logger throughout, sometimes they have to wait in a queue as well to be written to your screen. So let's quickly do this. I am now going to press the little button there called export 1. And there we go. That was super fast. That's only 3 records, right? So let's follow what worked here. So my controller triggered the export. The request worker passed on SOP. And then the request worker said, all right, I received the export. I need to start it. Then we saw the transform worker passing on SOP before the actual data from my little server came back even. Right, so this SOP traveled already while my other thread is still requesting data. So once that data came, we started reading and transforming, in which case you can see there's 45 bytes and 48 bytes on the last one that I've written. And another thing you saw here was that the file was open once transform worker passed on the SOP process type. All right, and that's it. That's how it works. We've got transformer worker, yes, and then the file at the end. And this is what it looks like. No, wrong one. This is it. So as you can see, we've got little logic that made this a valid JSON at the end. So let's do that exact thing now, just as is, with more data. So you can see the effect again. Right, so here we go. This is 1,002 records, I think. And there we go, we're done. So almost in the exact same speed that we did 3, we did 1,000. And we found that that doesn't change a lot unless you're starting to work with 500,000 plus records. Then you start seeing speed issues, but that's only because we're deploying on smaller machines that we're actually developing on. So that's what I found there. That is how we did this. So let's quickly go back to my presentation and just recap. I actually skipped a lot because I realized I don't have as much time as I thought I did. Like I said, you guys, I talk a lot, right? So there I already explained all of this to you. This is the connection. I'm sharing this with everybody, by the way. If I'm not mistaken, there's a way for us to do this, right? So I can share this presentation? Great. So you guys can actively look at those pieces. Right, so here, the interesting part, the outcome. So each developer worked on a single and used queue task to react to data. So on a single process, right? There was no lengthy meetings between all of the developers at all. What happened was each developer only spoke to the developer that was affecting its queues. Other than that, there was no need for big meetings. So that cut out a lot of our time as well. We had simultaneous development on multiple aspects, yes. And then if everyone adheres to the requirements of the queue contracts, integration was seamless. It was all of a sudden everything just worked in exactly the way I showed you now, except with 8 threads and hundreds and thousands of data, but the concept still remains the same. What happened in consequent projects for us after that, boilerplate code was drastically reduced because these components were so generic that we could drop them in again in the next projects we are using. When we need a file reader, we've got a file reader. It might need small adjustments, but not really, right? The tests that went with this that we wrote initially could be copied to the new projects, which means we don't need to test it again or write new tests for similar processes over and over and over again. We delivered in half the time initially, and we pretty much readied our projects to move to common code repositories, which our sys team has been diligently working on for us. So this is what happened. Our initial project took 4 devs 4 weeks to finish the first one. And our second project, we had 60% reusable code. It took 2 devs 2 weeks. And our third project, we was a massive Kafka project, 85% reusable code. 1 dev, it took them 1 week to deploy because of our reusable code and using this method to deploy fast. I'm not saying this is always the best method. It depends on what you're doing, obviously. But when you're working with processes in steps, this is a very nice way to make sure that everybody gets their piece to work on. So I think I ran a little bit over time. I'm so sorry. But are there any questions?
Yeah, that's okay. That's okay. You are on time. So we have one question. So
yes.
Stephen is asking if you can say a bit more about why async IO wasn't suitable.
Okay, in this case, async IO wasn't suitable for us for 2 reasons. Number one, the skill level in our team wasn't that high to be able to quickly learn how this works, everybody in the team, right? So if one person knew this, then it wouldn't be sufficient in our 4-week period that we had to build. So we, first of all, looked at all the knowledge that we had, right? Second of all, the async IO library gave us a little bit of issues purely because we were having difficulty tracking what is happening where. Some processes happen before others, right? So what would happen is the end of file would occur before, or there would still be 1 little item left to write. And we couldn't really figure out at that moment exactly how to resolve it in the POC. So what we decided was to rather go with something we know and work, and that's it. So we might even look at async IO going forward in order to improve this project, but I think it would not have worked out as quickly for us on development time at the end of the day if we went with it.
Okay, cool. So 2 persons are asking if Celery will be an option and if you are considering to open source the project.
The open source, this project, well, we can look at that definitely, right? Because this code is quite generic. I do have a sample of the code that I'm going to share with all of you at least, but it's something I could consider. Yes, definitely. And please repeat the first part of this question. I didn't quite hear it.
They were asking if you did consider Celery as an option.
Actually,
project,
no, actually, I did not even consider that. Now that you mention it, I kind of can kick myself, right? But yes, I'll definitely look into it and perhaps see if I cannot build a better process using it. Thank you very much for that, by the way. I've got one more question in-house here.
I was going to ask, you're running CPU bound as well. It's not only IO bound, the threads.
Yes. No, it's CPU bound as well. So what would happen is your threads.
Repeat the question.
Sorry. Yeah. So the question was whether our threads are only IO bound or CPU bound as well. Right. In this case, Python threads naturally gets distributed over your number of cores that you've got. So we basically split off the threads in a round robin fashion, core by core by core. So if you've got a dual core processor, half of your threads will sit on the one core, half of this on the other one. Right. And then with IO as well, as you see, all IO comes back to the main process that holds the queues, and it is the one that basically distributes it, the queue mechanisms in the background. But all the memory spaces are in the main file for IO. So it's just the other way around. CPU threads, but IO is all based on the main process. I think I've got one more, or am I time up?
One more and then you're...
oh, this hardware, this is on a 16 gigabyte Mac, right? So speed, yes, very fast, but there's a reason for it. It's my machine. Excuse me? Oh, in production, yes, interesting. We are running this on a 250 megabyte RAM and 252 CPU units on AWS. Yes, and it's currently operating. We exported, I think the biggest one we did was 400,000 products, and that took about 11 minutes on a small machine like that. So our idea was that if we can make it work on a small machine like that, then we can only improve. If we need to make a quick performance increase, then we just increase the size of the machine on AWS.
Okay, perfect. So thank you very much. That was really nice. So I'm going to, in behalf of everyone that doesn't have a microphone, I'm going to say thank you.
Thank you very much, guys. I appreciate it.
If anyone wants to keep the discussion going, just go to our Slack and Clayton is going to be there, so you can ask more questions.
All right.
So just a reminder, we're going to give some time Santiago to prepare. We have lightning talks at the end. There is a link in our Slack that you can subscribe to them. And Ivica, maybe you want to talk about the raffle, so everyone, people that were joining now will know.
Yes, that's why I'm here. So essentially, there was a quiz. I sent a link over on Slack. The quiz is now closed. Thank you very much for joining. So I'm gonna pick the winners right now. Just give me a couple minutes to put everything. And coincidentally, we're gonna use Python to pick the winners because it has a nice random module. So we're just gonna randomize through a list and pick 3 winners completely at random. I just need a couple of seconds to get everything ready, and using someone else's machine isn't always the best thing to do so, but
you're not sharing the screen. I don't know if you want to, to show what you're doing. So.
Exactly. I'm not sharing the screen because there's sensitive data over here and I don't want anyone to see.
That's a good idea.
Exactly. So names will be visible, but I didn't want to show any emails because secrecy, GDPR, lawyers, stuff like that, right?
Good idea.
Cool. That's always a good idea. Okay, let me see what I can do here. Nice. So I will be sharing the screen right now. I'm sorry for not looking at you. I need to look into what I'm doing. So share the screen. I'm going to share myself. Damn, I'm fat. Okay. Can you see the code now?
Yes.
I hope you can. Nice. So as you can see, there's 13 participants. And there's, as I said, there's a bit of Python code that is going to pick us winners, and when a winner gets chosen, thanks to this wonderful pop function, thank you, we're going to remove them from the list, so no one is going to win 2 prizes. If you hope for it, I'm sorry, it just doesn't work like that. Okay.
Cool. Okay, so first one, what was the prize? Was
So the first prize is the Effective Python book.
Yeah, really nice book.
It's an updated edition, second edition, really up to date in terms of code practices and everything else. And it's if I understood it, it's a collection of 90 specific ways to write better Python. So it's not for beginners. It's for, I would say, people who are versed in Python but would like to step up their game, which is always nice. Okay. The second prize is the Raspberry Pi Model 4 with 4 gigs of RAM. You can even run, I think, Minikube on it or something. And of course, the first prize is 100 euros, a voucher for shopping on our website. If you need some nice clothes or whatever, you can just use it. Okay. So I'm going to run the app now, and we say the winner of Effective Python, so this book right here, is someone named Margot. I will make sure to contact you once all of this is done to get your details, and then we will send the physical book to you. Congratulations.
Congrats,
yes. Woohoo. Now, second prize. Who wants a Raspberry Pi? I'd like one. Okay.
Yeah,
so let's see who it goes to. The winner is Eduardo. Congratulations, Eduardo. It's a nice little computer. And now let's see who's going to look fancy.
Yeah, I hope Eduardo is in the Netherlands or close, so you can send it.
Yes. Okay, so a 100 euro voucher goes to Aryan. Congrats, man.
Woo!
Yay! So that's it from me. I'm going to stop sharing now, and I'm going to introduce our next speaker, which is Santiago. It doesn't click. Yeah, now it clicks.
Cool.
Okay. I'm going to do a screenshot.
So I will use this time to say thank you, Vika, for helping us organizing this meetup. Thank you for hosting.
Of course.
Yeah.
Anytime. We're here.
Super nice. We need people to do that. We need speakers. So if you want to be a speaker in the Py.Amsterdam meetup, like Santiago, is the second time for Santiago as a speaker in our meetup. Thank you, Santiago. We need more people like you. So you can go to our website, Py.Amsterdam, and you can propose a talk there that we can use for our next meetups.
Yes.
Santi, I think you are
yeah, sorry.
ready to
go. I would like to add that our beautiful website was built by Ivica's wife. So
nice. Thank you.
Thank you. Yes, thank you, Maria.
I'm closing some apps. I'm gonna open what I need, and I will share my screen. 1 second. What is the Zoom here? Share screen. Okay. Share. Do you hear me well?
Yes.
Okay. And in Mac, if I press this, yes. Awesome. Well, hello everyone. I'm Santiago. Thank you for having me. Today I will talk a bit about the commitizen and how to automate your releases with it. I'll start with the introduction of myself. I'm Santiago. I come from Argentina. I'm living here in Amsterdam, where we are now. Thanks here all the people we are actually for, but thank you guys. And
Are
I
you
do
keeping the 1.5 meters distance?
of course, more, because it's so we have a lot of space. So, and I work mostly with Python and doing web stuff, and also with JS and whatever I find interesting. In today's agenda, wait 1 second, I bring my water. I'm back. Do you hear me well, right?
Yes.
Okay. First, I will start talking a bit about the history of the project and how it was born. Then we will discuss the release workflow I'm thinking of and that I like. Then how commitizen can help us to do this. And then how we can customize commitizen itself. Okay, first, bit of history. Commitizen is an open source project I started, I think, around 3 years ago. It was born as a prompt to avoid remembering commit conventions. I saw a super cool JS project, which was prompting the some questions, and I was like, oh, I want something like this. And it helps me remember, for example, conventional commits, which I like, but also work conventions, and whichever convention you find in a project, you can basically code it into commitizen and use it for different things beside the prompt. In the beginning, at first, when I started with the project, I wanted for it to be extendable, to let people build your own rules. Because for me, it was not only about a conventional commit, but for any kind of rule. Especially at work, there were different rules. And then I thought, okay, with this information, I can infer the version. I have information in the commit. With this, I can create the version. I was, oh, cool. And then I was like, but I can also create the changelog. And there are a lot of projects doing this, but there were none for Python. And I thought, okay, I will start coding into it. So I started with the prompt and was quite useful for me for some time. And then I started building the auto bump version. I was getting tired of checking what kind of bump should I use in my version. Okay, this is a major, minor, what? I have this information. Why don't I just code the auto bump? So I did it. But then I stopped investing much time on it. I was not working much. I didn't have a lot of motivation to do it. But a guy from Taiwan appeared, Liwei, and he started contributing more and more. And I also made him like part of the project. We moved it to a separate group repo. And he was actually the first to create the auto changelog MVP. And from that point, I found some motivation again to continue finishing and improving the auto changelog. So I invested some time and I finished what we have now. But of course, we always introduce some patch or a fix. And now we are both of us coding in it, and he even planned some sprints and stuff. Really good guy. So that was the history. Now, this is important part, the release workflow. It can be applied to any kind of language, but at the moment I'm gonna focus on Python. Usually in the workflow, we have a human which checks the pull request, makes comments, gives feedback, and once it's approved, it's merged. From that point, what I want is to automatically bump the version and generate the changelog. Usually, we have to do this manually, but I get tired. It's like a repetitive process that can be automated. Then once you generate the tag and the changelog, you push back to your branch. And from that point, because you have a tag, you can trigger a deploy or a release. Let's say you publish your Python package. Let's see in GitHub Actions how it would look. It's just would be 4 files, one in charge of bumping the version, the other, of course, publishing the docs, another action checking the pull request, and the last one is for publishing the package. So if you don't know, GitHub Actions is basically a YAML file where you specify when to execute that action. And here I put some examples. For example, the pull request on pull request. There is not much more. And in there, you can execute your test, your linting checks, etc., whatever you want. Once those are passed and a human reviews, you merge. And then once that is pushed to your, let's say, your main branch, usually master or trunk, you can trigger the bump version. There is actually something called Git trunk convention, which is different to Git flow, which says that you should merge everything into a trunk branch, your main branch, like small branches, and go to the trunk, and that gets deployed. So it's like a fast iteration. So on push to this branch, we trigger the bump version, and that will, in this case, create the new version and the changelog, which will be pushed back to your main branch. And this, because we are also pushing the tag, it will trigger this last one. You can see that based on the tag, in this case, if it has a version and anything that comes next, we want to trigger these actions, which can be publish the package and the documentation. And here is where commitizen comes into place. Actually, in this, I have highlighted this one. And this part is the one that commitizen is going to take care of. Like this, the push back to your branch is not that hard. And trigger the deploy or release depends on the language and what kind of thing you are doing. So commitizen cannot do that. So it takes care of the version and the changelog. And I think these are key elements of a release. And it's important. It's important to have a relevant version and to give feedback about what has been introduced, right? Okay. And the version, that's why we use Semver, and we generate the change. Now let's see some commands on how to use commitizen. When creating these commands, I try them to be intuitive and to have same defaults, to make it simple. I hate it when I have to add a lot of parameters and think about complex stuff. It's like I want to type help and give me the information I need. So the first one is cset init, and basically it creates a TOML file. When you type cset init, it will assist you in the creation of this file. You can, of course, write it manually, but with this, it detects some of the tags. It asks you, is this your latest tag? So you don't have to seek it. Also, it can show you the different existing rules, in this case, conventional commits, and you can choose, and some other stuff. And then you have it there, and you don't have to do it manually. Otherwise, you would have to go to the documentation and read the configuration and copy paste the file. It even asks you if you want it inside the PyProject TOML or in a separated file, which is .cset. And usually this command is executed during the project setup. Or if you have an existing project, you just run it once. It's not going to be run every time. Then we have a cset commit, which assists you in the creation of a commit which will match the defined rule. By default, the conventional commits. And this one is executed usually during development. Of course, this is optional because it's not needed. It's just a prompt that will guide you into creating a correct message. But if you already know, like I'm going to introduce a fix, you don't need to use it. Then we have the changelog. This one generates the file, the changelog file. And of course, it doesn't have to be named changelog.md, which is usually the default or what most people choose. But it has to be a markdown. It will generate markdown. It doesn't generate other format. And of course, well, not of course, but this is actually optional because you have cset bump -- changelog, and this one will generate both. You can type cset bump and ignore the changelog, which won't be generated. But I think this is the command I end up running most of the time, which creates the bump, the new version, and includes the changelog. So the bump will create a new commit bump from version to this version, and inside that commit, it will include the changelog. And this one is the one I expect to be run in the CI. So once you merge to master, the CI picks this new commit, runs cset bump changelog, detects the kind of increment needed, and creates the new tag and the changelog, and then it's up to you to push it back to your main branch. And lastly, we have a lot of other commands. For example, cset ls, which lists the commit rules. We will see later that you can customize your rules. So with ls, you can check, oh, I have this one. Then check, which validates the commit. Is useful for hooks. And you could potentially put it in your CI, but I think it's best if you add it as a pre-commit, like before the developer is going to push. You don't want your whole pipeline to fail because of a check. It's better if you do it locally, like you start typing, you commit, and it's no, this is incorrect at that point, instead of waiting. It's a lot of waste of time. And then the last three in this case are for mostly for documentation. This tool, I built it mostly for, it's for teams, so it's important to share the knowledge in an easy way. So my idea was, I don't know if people use it much, but my idea was that this kind of information should be condensed in this app as well. So if you type schema, you see how it should be defined. An example, okay, give me an example. I want to see how it looks. And then info, it should explain why it was decided that way, which happens to many of us. Like we are using a convention and we are like, but why this? So in this case, you can put everything into the application, and the application will give you this kind of information. And most of the commands are customizable. Now let's focus on the version bump. As I said, it follows Semver and calculates the new tag based on the commit rules. And this is a mistake, actually. It's not the last tag, but it's the version defined in the TOML. There is where we keep track of the latest version. This way, we don't have problems with the order of the commits. You know which one is the last, and that way you know which one should be the next. Let's see. And of course, as we saw, it has the ability to create the changelog. So I played with some tools and played around, and usually the problem is with the changelog is that you get the commit with the new bump, but you don't get the changelog, or the changelog has unreleased, but you just created the tag, and it's like a cycle. So bump with -- changelog kind of solve this problem. And also you could divide it, but let's not. It works for both cases. So I know people don't find Semver appealing, so fear Semver no more. With this tool, you let commitizen handle it for you. And what is important to me is that a Semver version has information, which is usually useful for me when I look at a new release. Let's dig a bit. First, you have, when you see a major change, you know there are breaking changes. Usually this means I have to go to the changelog and read what happened, what are the new things introduced, how they affect me, if they affect me, and how can I fix this. Then the minor usually means new stuff, like, oh, a new feature. You can go, it's optional to go to the changelog to see what's new, but it's up to you. You don't have to. And the last one, one thing, if you have a minor, you don't expect breaking changes. And the last one is patch, which usually introduces a security fix or bug fixes. It's important to point out that maybe a major version, a major may contain fixes, same as new features. It doesn't mean that you cannot introduce. And usually you are not bumping. You can have a bunch of commits, fixing stuff, introducing new features, and you only release a new minor. You are not releasing a patch or a minor. In this case, we can see we have a 2.23, like the measure is 2. This means that there has been 2 releases that introduced breaking changes. Maybe more stuff, but at least we know there were 2 breaking changes. And you can read in the changelog. Then we have the 23. We know for the second version, it has 23 at least new features. Maybe it introduces some new patches, bug fix. And then from this release, there were 3 bugs probably, or security fixes. So it's kind of a relevant information, and you can parse it and play around with it. And even, for example, in JavaScript, you can upgrade, but depending on how you write the version, it knows that it shouldn't update to a breaking change, but it can update safely this. And of course, you trust the developers who are releasing this. You expect them not to break. But if they do, they have to release a patch fast. Okay, and that's basically how it works. I don't think it's complex. And then how can we customize? Maybe I don't like conventional commits, so I can write my own rules that I want. For example, I could have just putting measure in front of the commit message, or minor, or a patch, and I want that to be my rule. So you tell your whole team or your teams, hey, introduce in your message measure, minor, and patch at the beginning, and colons, and that's it. And then for the bump, for the version bump, you need to write 2 regex. First, it will be one for to detect the change type, and the second is to map that change type to Semver. For example, we will have to write a regex that finds the minor, patch, and measure at the beginning, and then another one saying, in this case, it's quite silly because it will map minor to minor, measure to measure, or patch to patch. But for conventional commit, fix maps to to patch, fit to minor, and then if your commit message contains the breaking change in uppercase in the body of the message or with the exclamation mark in the message, it says, okay, this is a breaking change. So you have to map that. And then for the changelog, it usually works by default. I think this presentation is already on GitHub. You can clone it. And if you install pip install commitizen and run cset changelog, it should generate a basic changelog. For more, of course, we have documented most of it, and or you can use the template plus the documentation. It's a lot of help. And okay, what's the future for this app? Let me see if okay. What's the future? I think I've explained quite a lot of commitizen. It's a simple tool which does useful stuff. For the future, we plan on adding more format files like JSON, and in that way, it could be used even for JavaScript. Then we want to introduce a GitHub action. This way, you don't depend on Python. You just have the action there, and you can use the cset bump -- changelog, and it will do it. And we are also hosting a sprint on the next EuroPython. So if you want to join and help us with some bugs and stuff, you're welcome. Okay, so quick recap. We need an initialized Git repo. Then we run cset init. If we have files, we add them. We git add. Then we run the cset. This is the shortcut, cset commit. It will prompt, we fill it, done, or we can type git commit, and then cset bump -- changelog. This is a typo. This shouldn't be here. Ignore this. I will fix and push later. Okay, now a quick demo. Let's see. Can you see my screen well? Should I make it bigger?
I think that's okay.
It's okay. Okay, we have, let's see, we are in a cset demo folder, and we only have a virtual env. We are gonna check if commitizen is installed. It is. I did pip install commitizen. That's it. And now I will try run a command, but it fails because there is no Git repository detected. There is a bug there I reported yesterday because, for example, this one, I want to see the example and it shouldn't show this, but it doesn't matter. So I'm gonna create Git repo. So now I can initialize set, and in this case, I want to use this file. This is a toml, and I want to use conventional commits. There is no tag. It will set the default to this. The format, this is because sometimes there are some tags that start with V, then the version, and some others don't use the V or version or whatever you choose. You can format the way the tag looks. And now we have the Git folder, the systoml, and let's see what we have. It specifies, okay, the name, the default, and the tag format. Actually, only this one is required. I don't need. If I skip this one, it will use the default one. So in this case, we have cset conventional commits, version 001, and the tag format is $version. Now I'm gonna create a file, git add a. I will create an empty changelog. Let's see git status. They're there. So I will commit. Let's start with this, with the prompt. it shows me stuff. So I will start with the feature, the scope. In this case, I can skip it. Then the subject. We have in the documentation a page that explains how to write commits. Of course, it's optional, but I find it really helpful. And one of the best recommendations I've seen is to think about what, when I write the commit, I think this commit will ... what will introduce when I apply this commit. So in this case, of course, is dummy, but we could say this commit will feature a new pipeline for users. I don't know. This is, we don't want the body nor footer. If you don't know conventional commits, it's best if you search in Google conventional commits. Basically, it's adding the change type at the beginning. It can be fix, fit. You can even use docs. Docs won't be picked up by commitizen. It only picks up code changes. Let's say a fix, a feature, when there is a breaking change or a refactor. But the docs is skipped. What else? Okay. So we now have git log. We have a commit here, fit new pipeline for users. And now we are going to bump with the changelog. Because it's the first one, it prompts, it tells you which are the possible causes, because it didn't find a tag in your git log. It's a possible cause. Version in configuration is not the current version. This is because the current version in the toml should match an existing tag. So if they don't match, it means there is a problem there, and it's preventing you from making a mistake. And then maybe you have an error on your tag, or as it says here, is this the first tag created? Yes. So because we introduced a feature, it bumps. It detected a minor change, so it bumps the minor part of the semver. When we do git log, we have a tag, and the bump commit. Now let's introduce git add d. Now I can write like this: fix a broken pipeline, and let's make git add this file. No, in this case, I'm gonna use this. Let's introduce a breaking change. It's a fix as well. Yeah, for the users. It's actually this commit will fix problems with everyone. Is this a breaking change? I would say yes. I should expand there. So now in the body, it introduces breaking change. I don't remember if here should be the description if I write. But let's see. Git log, we have this fix and this fix user problems with everyone. So I will run, so that bump, changelog, increment detected, measure, tag to create 1.0.0. One thing I didn't mention is that usually when you are in 0, when your measure is 0, it means you are in an alpha stage and that you may want to change the interface. So for people using your project, they should expect changes. And it's up to you when to go to the first. But when you go to the first, you're basically saying, I want to, this will be my stable API, my interface for my users. Of course, it can happen. It can happen that you have to introduce another breaking change. So you can do it, and you should bump this version. Commitizen can do it for you. Of course, people usually is like, oh fuck, breaking change. But at the end of the day, it's maybe the best. I think a team, I think they are doing it seriously, is Angular. They are on version 10 already. And I think it's because of this, because they don't fear introducing breaking changes, and they just, okay, we are introducing breaking change. This is new. I suppose they collect a lot of breaking changes, but they bump quite fast. And let's see the results, git log. Our latest tag is 1.0. We have breaking change, fix. And let's see how the changelog looks. So, of course, if you take a look in GitHub or Bitbucket, it will look different. But we see the 0.1, it's a feature, and introduces a new pipeline. This is the date when it was released. And for a 1.0, it has a fix. And it says user problems with everyone, broken pipeline, everything is there. And that's it for the demo. Of course, this is done manually, but the CZ bump changelog is supposed to be running your CI, so you don't have to worry about this. And then your CI can also push, deploy either to production if you're building an app, or to the Py. Okay, let's go. Some questions, and before starting with the questions, no, it doesn't matter. Okay. Questions?
Thank you, Santi.
You're welcome.
Thank you. So I don't know if there is no question on Slack so far, but if anyone wants to ask one, it's time.
One question I have here.
Yes. Okay, so my question is, when we version bump, right, is it absolutely necessary that we use specific keywords in our commit message, and everything revolves around that commit message in this case? So if we were to incorporate this in a pipeline, then we can be rest assured that we need to make sure that it follows our convention.
Yes, so he's asking me if in the message there is a keyword that is required for the version bump. And the answer is yes. And that's why we have a check that you can check that your commit is valid, and you can execute it as a hook or in your CI as part of the pull request when you are running the test and stuff, in order to avoid having commits that don't comply. But also, if you receive a pull request in GitHub, you can squash and type yourself the message. So even if you receive a pull request from someone that doesn't follow, and they send like 5 commits with the update, new stuff, and then you look at the code, it's really good. You maybe don't need to tell the person change your commits. You can just squash yourself and put feature, a super cool new thing by someone. And it's more
important, that part. Thank you very much.
You're welcome. And another thing worth mentioning is that this may not fit for everyone. For example, I was thinking, if you are developing Python 2 and 3, I wouldn't know how to release new fixes for 2 and new fixes for 3 with this tool. But I think if you are building a new open source project, or you already have something, you're following kind of Semver, you can play with it, and at least CZ changelog, it will show you something, and that's it. And you can take a look at the commitizen repo for GitHub Actions. We are using there, and it's automated. When someone merges code, it triggers all the pipelines and deploys and publish the new version. That's it.
Cool. Thank you very much. Bravo. So thank you, Santi. So yeah.
Thanks.
So
You
your
can find me
second time
on.
as a speaker, we should give you some prize. So you will have a t-shirt when we print one. But we don't have t-shirts yet.
I want full.
Okay, so that was the last talk. We have the lightning talks now. We only have one. So I think, let me find the name of person. Just a second, sorry. If anyone wants to present a lightning talk, it's now. So Abdul, can you raise your hand so I can give you permissions to share?
This?
Okay, Abdul here. So Abdul, I'm enabling you to start your video. Should be able to do that.
Okay.
Hello, how are you doing? Welcome.
Yes.
Welcome.
Greetings. And
Then I will give you permissions to share screen. So
okay. When does my time start? Now?
It's now. So you're the only one. You send two, but I would say you need to pick one.
Okay, the first one.
Okay, cool. So you can please share your screen, and then I'm going to measure the 5 minutes.
Okay. Okay. Can you see my screen?
Yes, I can.
Okay. So basically, what I wanted to show is, by the way, can we put that slide? Okay. Okay. So if you don't mind me, I'm not sharing my video because
that's okay. That's
okay.
Okay. That's not a problem.
Okay. Yes. Just for example, that's the Plascon website. It's just a static website, nothing fancy. Okay, and you can see the talks here. Okay, it's just a static website. Nothing. There's nothing like no backend. Okay, and here's the repository. And if you see the requirements, we use Flask and a package called Live Reload. Live Reload is just a package that watches your files for changes and then applies and just runs a command. For example, here we have a custom Jinja function that just generates a file, and then we just use Flask as the WSGI app for live reload, and then we just watch the current directory, and that's it. And then since it's hosted on GitHub pages, for testing, you can run this server to see the output. And practically to run the project, you just need to run the static .py file, this one here, and it will watch over the changes. And then you run the server inside the docs file, and here it is. That one is here, the one here, and the shell here. It's the live watch. And for example, on the source file, I'll just remove. First, let me confirm something on this page here. You can see, if I refresh, you can see 2 points. You can see those two dots here. And then if I go to the source, I just erase the 2 points, and then I refresh. Well, that's why the live demos are for. I don't know.
You didn't save the file, probably.
Maybe let me just. I don't really know what happens. Like it always works, but only on well. Let me just retry one last time. Let me just maybe add the. I'm at 4 minutes. Anyways, that's a bit like.
So that's what's happening
Yes,
with the live demos.
Okay, so I think maybe if you run it, but basically that's an area that needs some some work, like how to have a Python replacement of Node.js as far as possible. Like basically Node.js, it is for example, when you use Vue, for example, what is interesting is that you just refresh your browser and then the site is rebuilt. So with the live reload, you can also have your less or whatever, SAS or whatever. You just download it as a command line. So you just have a command line something, and then use live reload to run that command line option, which generates which compiles your SAS file to CSS file. And it's the same thing as Node.js. I mean the live watch. The JavaScript syntax you won't get, but live reload is a nice package if you are interested into content. That's it.
Cool.
That's
So,
basically.
Cool, perfect. So you're out of time, but I will ask you: can you tell everyone when is FlashCon happening and what you have to do to join it? Because I think that's so we can give you a middle one, because I think it's a good conference. It's going to be online. There's a lot of communities working for that.
Yes, 100% online, and I can say that just follow FlashCon on Twitter. It's at FlashCon. Okay, on Twitter it's at FlashCon. You will get the updates.
So
but basically it's 3, 4, 5. Yes.
So the conference is free. You have to buy a ticket.
Yes, on no. It's yes, it's completely free, and it will be live streamed to YouTube, to the FlashCon YouTube, and basically it's Python Ireland who is on the live streaming part. Okay, so on Zoom. Normally for speakers they will be on Zoom, and it will be live streamed to YouTube for everybody to to watch, and it will be recorded. And yes, it's a very simple setup. No tickets, no registration, no whatever. You just watch on YouTube and you have the records.
Cool, perfect. Yeah.
And yes.
So
and
I was mentioning that because you were inviting us to participate, but we're, Jan
yes, I know.
and me, we are the only two ones in Py.Amsterdam, and we were not having a lot of time. So
Yes,
okay,
yes.
thank you very much. Thank you.
Okay, thank you.
So okay, I think we are done for today. Just a second. Yes. Okay, so thank you everyone. Thank you for joining. Thank you, Bestseller, Ivica, Santiago, and Clayton for the talks. That was really good. I will try to find some time to edit the videos and publish that the videos are going to be in our YouTube channel later. So yeah, thank you everyone. See you the next time. So July is going to be the EuroPython. We are participating there as a volunteer. So it's probably we are not going to host a meetup in July, but yeah, see you if you're going to join EuroPython, or otherwise see you next time. Okay, thank you. Bye.
Bye.